did you finish the like, did you get the final answer? I need a bit more time. Okay. Did someone have an answer? Okay. It was 14 degrees. West and north. 3.3. I'm not sure. I feel like I did something wrong. Well, Holly, yeah, actually, that's the answer that I got also. So 4.5 newtons. Although what I have is 76 degrees north of west, but that is just the same thing as 14 degrees west of north. So just going through with this one here, at least with the diagram would look like this for, I'm quite sure that the diagram would something like look like this. So with the diagram, at least now you are sure that it is in the, you have a basis that it is in the second quadrant, okay? So even without this figure here, we can just actually use, again, employ the component method. We actually call that one component method. So breaking down each vector to its components. So let's say for vector A, so again, I'll just gonna specify my X and then the Y. So it's north. So with the diagram that you have, if you can see, that's automatically that X is 0 because it's lying along the Y component. And then the Y is 5.5 nor or Newton. Okay, positive. Again, that is to represent the north direction. And then now for vector B, again, I'm gonna write down the X and the Y component. Y component in this case is 0, automatically 0, because if you can see, it's lying along the x-axis. So that means that whole of this particular value is just along the x-axis, and that is to the left, it's west. So that's negative 3.7 newtons. Now for vector C. So for vector C, I can, again, I will break it down to its X and Y component. So the X component is positive 2.6 Newton, but the Y component is 0 because, again, everything is, again, it's lying along the X-axis. So that means that that particular line, it has 0 Y component. And now for vector D, I have X, I have Y. Now, X component is automatically 0 because it is lying along the Y-axis. And now, for my Y component, it's directed downward, it's south. So instead of using the south, I use the sign negative 1.1 Newton to indicate that it is in downward direction. So that's the first thing. The second thing is you take the summation of all the X and all the Y. Okay, so all the X's. So X's, you have 0 plus the negative of 3.7 plus the positive of 2.6, and then plus you have 0. Okay, so you're just taking all the X's here. So X component of your A, x component of your b, x component of your c, and x component of your d. So this is the summation of all the x. And now for the summation of all the y's. So I'm just gonna take note of all the y values. So the y values here is 5.5, that's positive, plus the next value is 0, then plus uh, that's 0 again for C, and then for letter D that's plus the negative of 1.1. Okay, so take the algebraic sum for all the x and the y. So I'll just take the sum there, and that should give me 4.4. So this is 4.4, and it's positive, and that's a good sign because if you can see here, second quadrant y should be positive, and for the x that should be negative 1.1. Okay, so that's negative 1.1, and again it's a good thing because in the second quadrant the x value is negative. So somehow I made a correct representation of my vector, of my resultant vector, because if you can see, it confirms with my calculated values. So the third thing that you need to do is uh, solve the magnitude for magnitude. Okay, so how would you solve for the magnitude? Again, you use the Pythagorean theorem. This is x and y. So summation of all the x's squared plus summation of all the y squared. So that's the square root of negative 1.1. If you can see, regardless of your sign here, you should always get a positive value. Okay, because that's the square of a negative number is just a positive number. So the magnitude is around 4.5 newtons. So now for the angle theta. Well, you can choose this angle here, or you can also use the angle here. It doesn't matter. If this is my theta, so that means I'm looking at my summation of y, and this is my summation of x. So if I'm going to use tangent theta, opposite is summation of y over summation of x. So theta is just the tangent inverse of the summation of y. This is what I mentioned earlier, that just take the absolute value. So when you take the angle theta, you just disregard the signs of your x and y, and that should give you around a value of 76 degrees. So finally, final step is writing your vector r, or the resultant vector. That would be the magnitude, 4.5 newtons, and then 76 degrees. So in my case, I use the west as my reference. So therefore, north of west. Okay. So again, this 76 degrees is measured from west. So if you can see here, this is west. So that's the reason why. But this is just relatively the same. The value is the same for 4.5 newtons, 14 degrees west of north. So two of that answers either of the answers are acceptable. Okay. So any questions with this one here?
Yes, sir. When you like answer the angle, is there a absolutely significant here?
What? The significant digits?
Oh no, the absolutely for the angle.
This one here, absolute value.
Oh yeah, okay, I got it.
Yeah, because this is negative. If you have negative over a positive, that gives you a negative. But we don't mind about the negative sign of the angle or the positive side of the angle, because we're actually just getting the angle that is less than 90 degrees in this case. Okay. Because you might be thinking negative because uh, in your pre-calc, I think in pre-calc 12 or even in pre-calc 11, if you're talking about the negative angle, that only means that, especially for standard angle, we're not talking standard angle here, but in a standard angle, if you have a negative angle, instead of the rotation of a positive angle means a rotation of counterclockwise. A negative angle means you're rotating clockwise direction. So just for to provide, or at least to get rid of that misconception of the negative angle here, you might be taking this one. If you negative 76, you might be thinking that that is a angle measured from your positive x-axis and then rotating in the clockwise direction. Okay. Any other questions? Okay. Uh, if there's none, we can. We only have 12 minutes left, but I don't want to push this one out. Maybe we'll just have to continue example number 6 next time. So that would be on uh, Thursday. And so just quickly though.